We spend our lives tapping on screens, getting information in an instant. But have you ever stopped to think about what's going on behind the scenes? There's this hidden world, an invisible engine that makes it all work. Today, we're going to pull back the curtain on that engine.
Seriously, think about it. You're running late, you pull up a map, and boom, in seconds, it shows you the absolute best way to get there, even with live traffic. How on earth does it know that?
Or how about this one? You're shopping online, you throw a few things in your cart, you get distracted, close the browser, and when you come back tomorrow, everything is still sitting there, just waiting for you. It feels like magic, right? But it's not. And maybe the most important one of all, your banking app. How does it show your exact balance, down to the penny, every single time you log in, whether you're at home or halfway across the world? There has to be a rock-solid system behind that.
Well, the answer to all of these questions is the exact same thing. It's a concept that sounds kind of technical, but it's really the bedrock of our modern life, the database. You can just think of it as the super organized brain working tirelessly behind every app you use.
So, what exactly is this brain? To really get it, we just need to look at two main parts that work together to manage all this information. Okay, so at its heart, a database is super simple. It's just an organized collection of information. A perfect example? The contact list on your phone. All those names, numbers, and emails are stored in a nice, neat way so you can find exactly who you're looking for instantly. Yep, that's a database.
But here's the thing. A database can't do anything by itself. It needs a manager, and that manager is a piece of software called the Database Management System, or DBMS for short. This is the real engine. The DBMS is the gatekeeper that actually lets apps use the data, keeps it safe, and makes sure everything is running perfectly.
So what does this gatekeeper actually do? Well, any good DBMS makes 5 huge promises, 5 guarantees that make sure our data is reliable and totally secure. These are the promises that let us trust our apps with our lives. Let's quickly run through these, because they're the foundation of all digital trust. First up, consistency. This means that even if thousands of people are trying to buy concert tickets at the same time, the system won't sell the same seat twice. It keeps things from getting chaotic. Next, integrity. This is the promise that your data is accurate and hasn't been messed with. It stops weird duplicate info or unauthorized changes. Then you've got independence. This one's pretty clever. It means the data lives separately from the app using it, so when your banking app gets a facelift, your actual account balance data stays safe and untouched. Of course, you need confidentiality. This is the promise that the system acts like a bouncer at a club. It checks your ID and makes sure you only get to see the data you're actually allowed to see. And finally, availability. This is the promise that the data will just be there when you need it. It's constantly doing backups and getting ready for recovery, so if a server goes down, your info isn't gone forever.
Okay, so we know what a database is and what the DBMS does, but how is all of this information actually arranged? For that, we've got to look at the most popular and honestly most important type of database out there.
You might think it's some impossibly complex structure, but it's not. The huge majority of the world's data, everything from bank records to your social media profile, is organized into something you already know really well: simple tables, just like a spreadsheet. This is the whole idea behind what's called a relational database. Let's break this down real quick, because it's way simpler than it sounds. The whole thing you're looking at, that's the table. Each individual line going across is a row or a record. Just think of it like one person's complete contact card. And each column going down holds just one type of information for everybody, like name or student code. It's a super intuitive way to keep things organized.
But here's where the real genius comes in. Instead of jamming everything into one giant table, you can create separate tables for different things, like one for students and another one for clubs, and then you link them together. This is brilliant because it means you don't have to keep writing the same information over and over again, keeping everything clean and efficient.
All right, our data is all neat and tidy in these tables. So the next big question is, how do we ask it questions? How do we pull out just the specific piece of info we need? Well, it all boils down to 3 basic operations.
The first operation is called selection, and it's pretty much what it sounds like. It's all about picking out specific rows from a table that match whatever you're looking for. You're basically filtering your data.
So let's look at this student table here. We've got students, and we've got the code for what club they're in. Now, what if we only want to see the students who are in Club C2? We tell the database to perform a selection.
And bam, just like that. The database zips through every single row and gives us back only the ones where the club code is C2. We've selected exactly what we asked for. So simple, but so powerful. Okay, operation number 2 is projection. Now, if selection was all about choosing your rows, projection is all about choosing your columns. It's how we tell the database which pieces of info we actually want to look at. So let's use our same table. But this time, let's say we don't care about the student codes or the club codes. We just want a simple list of every student's name. We tell the database to project only the student name column, and this is what we get. We see just the column we need.
And now for the grand finale. The last operation is also the most powerful one. It's called the join. This is where that whole relational database idea really comes to life. A join lets us combine information from different tables.
So check it out. We have our student table, which links a student to a club code like C1. But that code doesn't mean much by itself, right? Then we have a separate club table, which tells us that C1 means dance club. To find out what Ando's club activity is, we need to join these two tables together. And this is what we get. The system uses that common club code to connect the dots and build us a brand new table on the fly that shows each student's name right next to their club's actual activity. This is how we get real, useful answers from what started as separate bits of data.
And that's really the secret sauce: selection, projection, and join. These three simple things are like Lego bricks. On their own, they're simple, but you can combine them to ask almost any question you can dream up. It's why this model has been the powerhouse behind pretty much everything for decades.
So the next time you check your bank balance, or book a flight, or even just see a personalized ad, take a second. Picture what's happening under the hood. Imagine all those invisible tables being selected, projected, and joined together in the blink of an eye. All of it happening just to bring that one little piece of information to your screen.